Suppose a loan of $25,000 having interest at 9% compounded monthly was repaid after a deferral period by monthly payments of $430 for 10 years. Let's try to determine the time interval between the date that the loan was taken out and the first payment. To start, let's note that we're looking for the time interval between when we took out the loan and the first payment. So let's take the first payment at the beginning of our payment period, so we're working with an annuity due. If that's the case, we know that we have monthly payments of $430 being given to the bank to pay off our loan. We know our future value should be 0. We're hoping to calculate the present value of this particular annuity if we know that the rate is 9% compounded monthly. It took us 10 years with the monthly payments to pay off the loan. 10 times 12 implies that we made 120 equal-sized payments. So first, make sure your calculator is set up in begin mode. Mine is, so I'm going to go ahead and begin with my value for n, which is 120, then going to my interest rate of 9. Going into the submenu, I need both of these programmed in as 12. I'm going to go ahead and quit the submenu so that I can get the equal size payment of $430 in as a negative value and our future value of 0. I'm going to ask my calculator to compute the present value of this payment stream. And we get about $34,199.51. Knowing this, our goal now becomes to try to determine the term in which our loan of $25,000 is going to increase to this $34,199.51. And we should be able to do this by applying the formula for n for typical compound interest, since there are no equal size payments happening in this deferral period. So let's take the logarithm of our future value of about 34.2 thousand, divide it by our 25,000, and then divide that by the logarithm of 1 plus I. Simplifying that expression gives us n is about 41.9. Let's go ahead and round this up so that n is equal to 42. And then to finish off this question, we want to apply our n is equal to t times f formula. If n is equal to 42, and we happen to know that the compounding frequency is 12, we should be able to solve for our term in years by taking 42 and dividing by 12. And this gives us that the deferral period must be about 3.5 years.